Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Mastering the Art of DevOps for Embedded Systems, brought to you by Tech Online, Wind River, and broadcast by AspenCore. I'm Colleen Heckman, and I'll be your moderator today. Discussing today's topic are Nitesh Goyal, Senior Product Manager, Wind River. Nitesh is an accomplished product management leader with over 12 years of global experience at the intersection of technology innovation and analytics, armed with an MBA and deep expertise in managing Internet of Things applications. And joining Nitesh today is John Jarboe, Senior Product Line Manager, Wind River. With a diverse and comprehensive background in product marketing, John excels at driving business impact across all phases of customer journey. His expertise spans development, support, sales, and marketing roles, offering both internal and external perspectives. It's with great pleasure I now hand things over to Nitesh to begin. Nitesh, take it away.
Quick introduction. I'm Nitesh Goel from Wind River, and today we'll be diving into the world of DevOps for embedded system with a particular focus on continuous testing. As most of you on this call, I'm also an engineer with over 15 years of professional experience. I have witnessed the evolution of embedded systems into intelligent edge systems. And hope we can all agree that the rise of intelligent edge systems have really changed the game. These systems now are complex. They often involve a mix of hardware and software with AI and machine learning thrown into the mix. They operate in dynamic, unpredictable environment, constantly interacting with the real world. On top of these systems are mission critical. They cannot fail. All of this complexity means the traditional ways of development and testing embedded systems simply aren't enough in the new age. So, in today's session, we'll explore the challenges that traditional testing method presents in the embedded space. We'll delve into the core principle of DevOps and how they can be applied to streamline the development and testing process for embedded system. And by end of this webinar, I hope you'll gain Wind River's perspective on implementing continuous testing to improve the quality, efficiency, and reliability of your embedded system development. So whether you are a seasoned embedded system developer or just starting on your DevOps journey, this webinar should be for you. So let's get started. A quick introduction about Wind River. At Wind River, we are a global leader in delivering software for intelligent connected system. So what exactly does that mean? We provide a comprehensive software portfolio that spans the edge to the cloud, designed to empower you to develop, deploy, operate, and service your mission-critical intelligence system. Founded in 1981, we have a long history of innovation in this space. Today, we boast over 1,600 employees globally, with a significant portion of our team dedicated to research and development, ensuring we stay at the forefront of technology. Our technology is trusted by over 2 billion products deployed worldwide from leading companies in over 20 countries. That success is due in part to our award-winning customer support, a broad partner ecosystem, and world-class professional services. We're also laser focused on building a collaborative and innovative culture. For 25 consecutive years, we have been ranked as a top workplace. We are headquartered in Alameda, California, but our impact is global. We have a strong presence of over 1,600 employees around the globe, and we are proud to hold the number one market share position in edge compute OS platform. At Wind River, we believe the future is intelligent. And we are not just talking about the latest smartphone or smart speakers. We are talking about intelligent systems that are transforming entire industries, from aerospace and defense to medical and automotive. So if you look at the slides, these are just a handful of leading global brands that trust Wind River to power their intelligent systems that are making a real difference in the world. Companies like Boeing, General Motors, Samsung, Bosch, they all rely on our software to develop, deploy, operate, and service their mission-critical intelligence system. Working with these customers have enabled us to develop a unique set of skills and depth of knowledge that allowed us to create a product portfolio that spans the entire spectrum of intelligent age, from VxWorks RTOS to WinRiver Linux integrated development environment, as well as simulation solutions for device edge to infrastructure edge, including telco grade ORAN cloud capable of scaling over thousands of nodes in a 5G platform. So we have just learned about WinRiver roles empowering the intelligent system revolution. These systems, from self-driving car to smart medical devices, are changing the world. But as they say, with great innovation comes great responsibility, especially when it comes to ensuring the safety, security, and reliability of this intelligent edge system. So today's focus is going to be on a crucial aspect of that responsibility, testing. Let's deep dive into the specific challenges we face when testing these intelligent edge systems. As we advance on our mission to support our customers in transitioning from traditional embedded systems to intelligent connected systems, we conducted ourselves a comprehensive research, engaged with over 700 developers, diverse range of customers. And this research revealed significant challenges in adopting the V model's best practices within the new age intelligent systems. One key insight was up to 60% of the bugs are found late in development. You can imagine the scramble, fixing issues that should have been caught earlier. This is a major problem because fixing a late cycle bug can cost up to 15 times more than it would cost during design, and a staggering 100 times more after release. Think about it. That delayed smartphone launch, those millions spent on car recalls, all avoidable with earlier bug detection. But it's not just money, right? Embedded systems power critical applications, from medical devices to automotive controls. These late cycle defects can pose serious safety risk. Early detections could have prevented that. Finally, let's not forget about customers. Late defects translate to bad experiences, product recalls, or even safety incident. The bottom line, late cycle defects are expensive, time consuming, and risky. So let's explore why traditional development struggle with these problems and how we can overcome it. In our view, traditional development methods often lack the four key ingredients necessary to be effective for testing the new age intelligent edge systems. These are expertise, access, availability, and automation. And I'll talk about each of them briefly. From expertise point of view, traditional development and testing methods often operate in silos, with developer, testers, and operations working separately in isolation. This separation means testing expertise isn't integrated into the development process. The safety critical intelligence systems require developers to write testable code and testers to understand the code nuances during development. In traditional method, this expertise is not always shared, leading to gaps in testing and affecting product quality. Second one, access. To accomplish effective testing, especially for applications that interact with hardware, it requires consistent and reliable access to the necessary hardware. The traditional development environment often struggle with providing this access to their geo-distributed teams. Hardware might be limited to certain teams or individuals, causing bottleneck and delays in the entire development process. Limited hardware resource are another hurdle. Budgets or logistics might restrict the number of testing rigs available to the team. Think of expensive, specialized equipment and not enough unit to test everything at once. This scarcity can lead to team skipping tests or insufficient test coverage, leaving issues undetected until later. And finally, the traditional methods often lack robust test automation. Manual testing is common, but it's slow and it tends to be error prone. Automated testing, on the other hand, can provide quick feedback, which is a huge advantage. However, setting up automations require a shift in mindset and upfront investment. The traditional development with focus on separate development and testing phases often struggle with prioritizing automation, leading to slower feedback loops and longer development cycles. So, having identified these critical challenges, our focus now shifts to exploring key enablers to shift left testing. And in the next session, we'll discuss strategies and tools aimed at preemptively addressing these issues, optimizing development processes, and enhancing product quality. Let's shift gears and talk about catching bugs early. Imagine a world where you identify problems before they snowball into major issues. That's the power of shift left testing, moving testing activities from tail end of development to the beginning, saving time and money down the road. So how do we achieve this shift left magic? In our opinion, here are the key ingredients. First up is cloud. Cloud-based management is really a game changer for keeping the testing processes standardized and centralized. With pre-configured test and environments readily available, teams can save time and enhance collaboration. This centralization allows for consistency and fast deployment of tests, making the workflow more streamlined. The second one is secure remote access. So you can test anytime, anywhere. So when we talk about secure remote access, in our increasingly hybrid work culture, teams need the flexibility to access tests and resources from anywhere in the world. The secure remote access not only facilitates this flexibility, but also ensures that sensitive data remains protected, especially in critical sectors like healthcare, aerospace defense, and automotive. This means that no matter where your team members are located, they can contribute effectively while maintaining high security standards. Next one is scalable simulations. Now consider the need for diverse testing scenario. Products like embedded system often require interaction with a wide variety of hardware configurations. And this is where scalable simulations comes into play. Utilizing the compute power of cloud, we can create these simulations without the need for physical hardware, which saves both time and resources for the teams. This capability allows us to test under various conditions and configurations, ensuring our product performs reliably in real-world scenarios. And finally, automation. Automation is really our friend here. We have continuous integrations and continuous deployment pipelines. These pipelines automate the testing process throughout the development lifecycle, creating a constant feedback loop. This means we can catch problems early and address them quickly. This is just the beginning. In the next slide, we'll dive into a specific platform, WindRiver Studio Developer, and how we integrate these capabilities to create a powerful toolkit for embedded systems development. Talking about WindRiver Studio, Studio helps solve the challenge of embedded end-to-end value chain, which traditionally has been fragmented and complex. Development teams struggle to collaborate efficiently, deployments can be slow, and operations are often manual and error prone. Studio Developer addresses these challenges by providing a unified platform for development, deployment, and operations. If you look at the graphics on the slide, on the left side of the graphic, we have development. WindRiver Studio Developer provides a cloud-based integrated development environment that allows developers to collaborate on code, build, and test applications and manage the entire workflow. With Studio Developer, developers can work together on projects in real time, regardless of location. they are able to automate those repetitive tasks, taking advantage of pre built components and templates. And another key advantage of Studio is it has been pre built, it comes and offers pre built integrations with a wide variety of third party tools that are industry standard. In the center, we have deployment. Studio Developer includes tools for containerizations and mixed criticality, which allow developers to deploy application to a variety of devices, including those with different safety requirements. Studio also automates the deployment process, which helps to reduce error and speed up time to market. And finally, on the right side, we have operations. Studio provides tools for monitoring and visualizing devices in the cloud. This allows operators to proactively identify and troubleshoot issues as well as optimize the performance of their system. By providing this unified platform for development, deployment, and operations, Studio can help you streamline your embedded development process, reduce cost, and get your product to market faster. What sets Studio apart from its other contemporary applications is its modular structure, offering the flexibility to adopt specific functionalities as needed, avoiding the costly rip and replace approach that many traditional systems require. Studio is composed of various developer modules, each designed to tackle specific development challenges such as complexity, security, and compliance. These modules integrate seamlessly with each other and leverage a common Studio developer infrastructure, allowing the users of Studio to adopt functionality incrementally based on their immediate needs. Let's explore some of the key modules that illustrate the power and flexibility of Studio. The first one is Studio Pipelines to automate and orchestrate the continuous build, continuous test, integration, and deployment process. Virtual Lab manages manual and programmatic access to shared, simulated, and physical devices. Test automation, standardize and share test suites and plans to system applications and component. We also have over-the-air update to manage multi-tier update campaigns for over-the-air deployment to fielded devices. And digital feedback loop establishes a reliable connectivity between edge and cloud systems for real-time data collection, analytics, and response. On top of that, we have Studio Gallery that extend the core functionality of Studio by offering seamless integrations with various third-party tools. This modular structure of Studio empowers customers and users to build a customized DevSecOps environment tailored to their specific embedded system development needs. In the next part of the webinar, we'll bring these concepts to life and explore how Studio Pipeline, Studio Virtual Lab, and test automation work together to create a cohesive and efficient environment for continuous testing. So here you are looking at homepage of Studio Developer. And first we'll be talking about Studio Virtual Lab. Studio Virtual Lab offers a secure cloud portal for managing and sharing distributed test environments, including remote hardware labs and modern simulation tools. This integrated solution empowers developers with comprehensive capabilities for automation, as well as collaboration among remote testing teams with distributed test environment. To access the functionality, you click on Virtual Lab, and you see this dashboard that then the users can utilize the Virtual Lab dashboards to configure the target parameters, monitor the target utilizations with ease. This also streamlines the process of managing test environment, empowering developers to efficiently orchestrate testing activities and optimize target utilizations. Here, developer can leverage the dashboard to view current, scheduled, and past reservations. Developers can come in, open any of the past reservations to review the specific settings, or you can reserve the target again with the same settings as it was configured in the past. This intuitive reservation interface allows users to target configurations to meet their specific requirements, providing greater control and adaptability in accessing target information and configuration parameters. Furthermore, Virtual Lab offers extended capability for managing target reservations, enabling developers to manually extend the reservations time, end the reservation, or open the reservation menu to find out the exact settings and configurations parameter as needed. If we look at the physical target interface, here developers can easily check the availability of target accessible to users per their role-based access control policy and add new reservations. The reservation powered time sharing of limited physical hardware resources in the time environment and the test environment untethers that one-to-one utilization of physical hardware to a one-to-many utilization model that unblocks and allows multiple developers or teams of developers to leverage the same hardware efficiently, promoting collaboration and resource optimization. In addition to managing physical targets, Studio Virtual Lab supports virtual targets and configurations, further enhancing flexibility and scalability, allowing developers to parallelize the testing of software with virtual targets. Out of the box, Studio comes with support for quick emulation tools, the QEMU models, but virtual app platforms also enables the flexibility for customers and users to bring their own virtual targets. For instance, here I'm showing Studio users can leverage their existing license for Symix technology to register their Symix targets with Studio and use it in a cloud native manner. In the context of virtual target, the concept of reservation is synonymous with spinning up a virtual test container. It, it is an ephemeral container that spins up on demand and hence it is budget friendly. This concept of virtual target enablement in a cloud native manner eliminates the high cost and long lead time associated with physical hardware acquisitions. But hard access is just the beginning. Studio Virtual Lab goes a step further. It's about taking control. So here you can see at any time you can come in, open a target reservations, and connect to the target shell, which is a crucial capability. Here, once you have access to the shell, you can automate the actions you want to execute against the target as part of your pre-testing setup or post-testing teardown actions. This bidirectional communication pathway with target not only allows for real-time monitoring and control, but also empowers developers to troubleshoot issues efficiently. In summary, Studio Virtual Lab provides a secure cloud portal for managing and sharing of distributed test environments, and with its powerful automation capabilities, intuitive user interface, and support for virtual targets, Virtual Lab enhances collaboration, efficiency, and flexibility in the development and testing process. Next, we will look at test automation framework. To that, we'll navigate back to the Studio homepage. Here you can see the test automation framework. What test automation framework enables is automated testing of embedded software changes from globally dispersed development team. TAP is a comprehensive solution that is designed to streamlining the testing process, whether we are talking about post-merge testing scenario as part of CI/CD or a more comprehensive yet less frequent system-level testing, catering to the diverse use cases among developers and testers. For that, TAP acts as a central platform for planning, executing, and monitoring tests across a wide array of software platforms, including Wind River Edge portfolio, as well as other embedded operating system and applications. So I've just clicked on tab to navigate to the dashboard. This dashboard for tab provides a centralized view of all test executions across test plans managed through tab and accessible to the user through their RBAC policy. You can see both active executions as well as completed executions on the dashboard. You can navigate to view all executions, and there you can filter out the executions to quickly find a specific one. What you will also find is as a TAF execution progresses, TAF offers an in-depth result analysis via user-friendly dashboards to facilitate assessing testing outcomes and pinpointing areas that need further investigation. These dashboard provides a consolidated view of testing status, results, logs, metrics for effortless monitoring and analysis. It displays key metrics like what's the status of the test, how many tests passed, failed, errors, aborts to provide instant insight into testing progress and outcome. This near real-time visibility empowers user to gauge testing efficacy and make informed decisions. Execution metrics and history can be viewed at the overall test plan level, or it can be viewed at an individual test plan level to give an overall view of testing for that particular test execution. For instance, drilling down allows viewing test results and log for each target that is part of the test executions. These detailed logs provide crucial context, helping user understand what happened during a test execution and if something went wrong, under what conditions the test did not pass. This translates into faster debugging and quicker resolutions, keeping the development process on track. Each execution provides a quick link to navigate to the related test plan for further analysis. One of the standout features in test automation framework is its flexibility in dynamically selecting and executing the test. This flexibility in form of test plan execution allow user to expedite the testing process. So here what I'm showing you is within test plan, you can, as a user, you can import your existing test and organize them in a logical, structured manner that we call test suites to efficiently validate target applications. Each test suites basically defines the subset of test cases that test related areas or features as part of that test plan. Test suites, when you're adding a test suite to a test plan, they're also added with any common configurations required to run the test, such as user credential, input test data parameters, or target environments. Looking at it, you can see a single test plan includes multiple test suites as needed. And this hierarchy of test plan containing multiple test suites defines the overall sequence and order that the selected test suites contained within a test plan will execute. The advantage here is it ensures that tests distributed across test suites can run independently and in a conflict-free manner. Organization of test cases into test suites and having an association with target environment essentially enables the test SMEs to bake their expertise into the test plan themselves. So your pre-configured test cases, test suites, and test plans sort of become a repository of knowledge, ensuring consistency, leveraging that expert insight across all testing activities. So as users, we are no more reinventing the wheel every time we need to run an execution. In the process of setting an execution, user have a choice to choose all test suites to be executed or a subset of test suites to be executed. That gives the flexibility to not run the whole plan for every executions to fit your evolving requirements. It's, as we say, it's a testing environment that bends to your will and not the other way around. As we have seen, when a test execution is completed, it gives you a real-time view into the status of testings. The execution status and results are continuously and automatically tracked, and key metrics provides the visibility into progress and outcome. In addition to that, historical executions are also maintained for each test plans to allow the user to gauge the effectiveness of plans and test over time. It also gives the flexibility to rerun the relevant plan as needed for ongoing validation purposes like regression testing. This hierarchical structure of organizing test cases into a test suites, multiple test suites into a test plan extends to what we call test project. A test project defines the top level construct for organizing test plans and configurations such that you can have multiple test plans associated with a single project. In a way, it establishes the process of having test project is that it establishes that logical boundary for permissions, facilitating team collaboration while ensuring that sensitive intellectual properties and test results remains isolated and protected from unauthorized access by other team members and project. Within a project, you define common things like credentials, where you want the artifacts to be located, your retention policies. Each plan inherited, any test plan that is structured under the project inherits these common configurations and can be customized independently with their own set of test suites, environment, etc. A key capability Another key capability in test automation is its extensibility through a plugin architecture that significantly enhances its integration with other capabilities within the Studio ecosystem and beyond. This includes plugin for target management, executions, and reporting of test results. Out of the box, tests include plugins and curated collection of test libraries specifically tailored for testing WinRiver operating system kernel. So here I'm showing the execution plugin for WinRiver Linux. And this provides studio users of WinRiver Edge portfolio a significant advantage in the validation and testing of their platform. But additionally, users have the flexibility to create custom plugins that can be developed to address their specific need. Whether you need to integrate proprietary tools, custom test harnesses, or specialized testing protocols, TAF execution plugins ensures adaptability and versatility, allowing users to address their unique challenges and test scenarios effectively. Studio offers a flexible infrastructure supporting CLI, API, and GUI options to cater to the diverse user preferences. While the intuitive GUI simplifies the configuration of tests, monitoring of test progress, and analysis of test results, for developers and advanced users, the CLI provides efficiency and flexibility, allowing for automation and scripting of tasks, which is ideal for integrating the testing process into the CI/CD pipeline. We also have well-defined API set that enables the integration of Studio capability into custom software solutions and automation framework, providing programmatic control over testing functionalities. Switching back into so far we have talked about the functional attributes of Studio Virtual Lab and test automation, but security considerations are paramount when the design of and operations of these features. Studio comes with an RBAC that spans across platform. It ensures that developers and testers have access only to the resources they need, adhering to the principle of least privilege. This approach maintains security, and prevents unauthorized access, safeguarding sensitive targets and intellectual property. Now that we have discussed the capabilities of virtual lab and test automation as standalone solution, I want to highlight how integrating these capabilities through Pipeline Manager offers a comprehensive approach to continuous testing across both software and hardware component. So the diagram that you're seeing illustrate the synergies between Pipeline Manager, Virtual Lab, and the test automation framework. Here, Pipeline Manager acts as that central orchestrator, automating the test execution process and automating and optimizing your overall test quality. It streamlines the entire workflow, ensuring seamless integration of various tasks involving fetching code from repositories, compiling and building the software artifact, executing best practices in code development such as quality scans, composition analysis, etc., and then managing the sequence of testing activities. Within the sequence of testing activities, we have Virtual Lab that enhances the setup by offering secure portal for managing and sharing distributed test environment, including remote hardware and modern simulation tools. The integrations of Virtual Lab within the Pipeline Manager empowers developers with capabilities for enabling remote access and testing with distributed environment, but also a powerful automation through leveraging Studio Virtual Lab functionalities through CLI. Similarly, the test automation framework takes the testing process a step further by automating the test executions, but also refining the test quality through its modular architecture and extensible design. By extending the pipelines to incorporate the hardware-based testing, um, organizations can achieve comprehensive test coverage across software and hardware component. Then mapping the test results back to requirement management tool is a critical component of this setup. It enables stakeholders to assess the test coverage against the project requirement and enhance the transparency and accountability in the testing process. This closed loop approach ensures continuous feedback and improvement, driving significant enhancement in testing efficiency and quality. So let's delve into the demonstration of this pipeline. Going to quickly check connectivity. For the demo, I will browse Pipeline Manager. And here I have configured a pipeline that has been crafted to demonstrate the continuous testing workflow. This automated pipeline streamlines the multiple critical steps, transitioning development team workflow from numerous manual steps to a cohesive, automated, efficient systems. So let's see it how it works under the hood. Basically, initiate a pipeline by fetching code from repository, ensuring that you're always working with the latest updates, followed by running development practices, best practices in parallel, such as we are running unit tests, we're doing static code analysis, you're also running your custom test, all springing to life simultaneously, significantly reducing the time to completion. For instance, these Python-based unit tests can verify your code functionality at a unit level. The covariety static code analysis proactively identifies potential issues, whether they are security vulnerabilities, before they get escalated. Other custom testing ensures thorough coverage by exercising all conceivable combinations of conditions and decisions in your code. Then you can compile the code using the correct compiler flags, ensuring optimized settings for deployment. The compiled code then find its home in Artifactory. This is the start of our continuous testing journey. And this is where Virtual Lab steps in, starting with provisioning the user of these pipelines to have access to the target environment, which has been tailored for testing. the think of test environment that we are using in this pipeline akin to a hill test bench involving a Windows machine that is orchestrating various data simulations and control system logic. Then we are swiftly resolving the Windows machine, securing a connection string for remote actions. We are executing actions against the Windows machines that those actions are seamlessly executed on the provisioned environment. And in this case, the script ensures and verifies the content of a specific directory and transfer necessary files to the designated test environment that is primed for testing. Then we comes the pre-configured test plans, defining test suites, specifying the reserved Windows testing environment, and configuring the required test arguments. The pipeline that triggers the execution of the the test on the designated Windows machine, capturing the execution logs to provide valuable insight. And once the test execution completes and concludes, the test artifacts that are generated are sent back to the Studio Cloud for analysis and report generation, offering clear insight into your test results and coverage. As a final act, um, the pipeline gracefully performs the tear down actions, removing any temporary files and unreserved the target environment, ensuring readiness for subsequent testing round. So let me run the pipeline and then we will review the results. Running the pipeline is simply clicking off a button, or you can execute that using CLI or schedule it. When you run a pipeline, um, I do want to highlight one thing. All of these actions that we just talked about that are laid out here, they are possible within Studio Pipeline because of its extensive third-party integrations that provide a comprehensive solution for modernizing the build automation workflow. However, in the interest of time and to maintain our focus on continuous testing, I'm going to focus on this aspect of this demonstrations where we'll look for the steps involved for target management and test executions. So as we go, so here you can see these steps are turning green, means the step has been executed. First, we have provisioned a gateway enabling the system users of the pipelines to have the secure access to the target environment. Then we reserve the target to have connection strings to be able to access the target. We execute some target actions. So you can see the logs, everything that's happening remotely. The logs are captured and available for in the cloud as centralized single pane of glass for the members of the team. So here we can see the file has been successfully transferred, and here the test execution has started. You can see as the test executions are progressing, it's going to generate logs. We can go here and look at the execution results. So this is a test that is currently in progress. We can see in the interest of time, it takes a while to complete test execution. So we're going to focus on a previous execution. I'm going back to the run here. So this is the execution that I just conducted. So TAF execution just finished, completing the TAF run. And finally, we have, after all the test executions are completed, the system tear down, clearing the target and unreserving the target and making it accessible for the next round of testing. So here is this full demonstration showcase the transformative potential of automation and streamlining your testing processes. Focus on continuous testing to achieve unparalleled efficiency and quality. So if I go back to presentation for a minute, the key takeaways, if I can summarize quickly, today we discussed the importance of early and continuous testing in the development lifecycle. By doing so, we can significantly reduce the risk of late cycle defects, which ultimately enhances overall product quality and reliability. Uh, what we have shown today is first, automated pipelines and parallel processing capabilities play a crucial role. These technologies drastically reduce testing time, allowing teams to operate more efficiently and securely. We talked about virtual lab, ensuring secure, consistent testing with scalable and flexible test resources. We talked about centralizing the test management and optimizing hardware uses across teams, this to break down silos and encourage a more integrated approach to testing. This not only improves collaboration but also ensures that resources are used in the most efficient way possible. Lastly, automated test executions combined with continuous feedback loop improves quality and reliability. So, in summary, integrating these key elements into our development processes allow us to deliver high quality product faster and more reliably. With that, I pass it back. Thank you very much for listening.
Well, thank you, Nitesh, for an excellent presentation. And to our audience, we're now moving on to the question and answer portion of our event. I'd like to welcome John Jarboe. Hello, for your Q&A expertise here. So I'd like to get right into the questions. So to our audience, if you haven't done so already, please go ahead and submit your questions now if you haven't done so already. Please note we'll get to as many questions as we can in the time left. If we don't get to your individual question, someone will get back to you after the program is over. So let's get started here. My first question asks, how do you incorporate PKI into CI/CD, like managing the certs and identities of workload, devices, OTA, etc.?
Yeah, that's a great question. Well, I mean, PKI can be used in a variety of different ways. This presentation, we're focusing on testing, so I guess I'll focus on that one as well. Probably the easiest to understand is the Wind River Studio Developer Platform includes PKI management capabilities within the platform itself. So, you know, managing your identities and your certificates and that sort of thing. And that's used in a testing context extensively for understanding whether users are entitled to access certain resources. So in, you know, kind of under the covers in the platform, each testing, like each hardware device has been assigned a unique certificate, so we know that the device is authentic, and each user has their own certificate. And the PKI infrastructure within Studio Developer makes sure that authorized users are connecting to, you know, legitimate targets, and we know who's doing what, and we verify that they're entitled to do whatever operation it is that they're trying to do. And if for whatever reason you need to rotate certificates or other types of secrets, that can all be managed through a central console within the Wind River Studio platform itself.
Excellent. Thank you, John. Next question asks, we find that fixing automated test failures can be really hard because developers need to understand the context of the failure. How do you help developers understand how to reproduce failures so they can fix the underlying problem?
Oh yeah, that's another great question. And they're right. You know, I mean, context is key. Within the Studio Developer platform, we keep track of like when you run a particular testing plan. You know, you have a list of all the tests that you're going to run, and as part of the artifacts generated by running that testing plan, that run, you know, not only the testing plan and the steps within the testing plan, but the test cases that are run underneath the covers and the commands that are executed to run the test cases. You know, any output that comes from the testing target, whether it's simulated or hardware, is also stored with that log. So you get that complete log of everything that happens within the testing run, and that makes it really easy for developers when failures are found to go back and see, okay, this is the command that was run. These are the results that happened. If for whatever reason, simply looking at that test case isn't enough to reproduce the problem, they can go back and look at which test cases were run beforehand, because maybe, you know, one of the test cases didn't clean up appropriately after it ran. And so they can go back through that history and really kind of reproduce the entire history of what happened on the target from the moment that it was initialized when Studio Developer connected to it until the failure happened, possibly, over the course of several different test cases running. And you can see that whole history and use it to reproduce manually if you want, for example, on a debugger.
Excellent. Thank you for that. Thank you, John. Next question asks, does the Wind River solution require the use of our Wind River OS, or does it work with other runtime operating systems?
Oh, no. Yeah, Studio Developer is it's a generic kind of DevSecOps platform. It's open, it's extensible, and really it can work with pretty much any runtime OS. That goes from the perspective of building the application that's going to run on the OS, as well as connecting from a debugging perspective, for example. We do simplify things, I guess, for Wind River technologies, because obviously we understand them and we want to make things easy for our users, and we know that some of our users are going to be using other Wind River technologies like VxWorks or the Helix virtualization platform. So we make it easy for those users by providing kind of pre-built build environments for Wind River edge technologies. But there's nothing preventing the use of third-party operating systems or kind of homegrown executors or operating systems. Things like FreeRTOS or Zephyr or any of those things will work just fine as long as you can take the build steps for that system and put them into a container. Then Wind River Studio Developer is going to be able to to use that container to build that particular execution environment for the application.
Excellent. Thank you, John, for that. I'm going to try to fit in a couple more questions to our audience. If we don't get to your individual question, don't worry, someone will get back to you after the program is over, so we do encourage you to submit any and all questions. So next one asks, we use Jenkins pipelines, and we have some automated tests. I think the simulation and hardware management could help us. Can we use just those parts, or would we need to replace Jenkins and rewrite our tests?
Well, I mean, the short answer is you have lots of options. I know that's not all that helpful, but I mentioned Studio Developer is an open, extensible platform. It has a variety of different ways to interact with it. There's a command line environment, a GUI, an API, and depending on what type of workflow you want to create and the disruption that you're willing to tolerate for your development team, you could do it in a variety of different ways, right? You could keep your Jenkins and use that to kind of drive things that are happening under the covers, whether that's running tests through Studio Test Automation or even just using Virtual Lab to connect to the test, and then you're going to run your tests using your own testing framework. That also works. You could also adopt Studio Developer at kind of the highest level, and then use that to execute individual Jenkins pipelines under the covers, right? Having Studio Developer or Studio Pipelines call Jenkins to run individual pipelines. So you have a lot of that flexibility, and it's really more a matter of what's going to be easiest for your developers to adopt and what's going to help you kind of move from where you are now to where you want to be with the least amount of disruption. In general, if you have specific questions or concerns, we're always happy to discuss, kind of what those options are, what your situation is, and help you find a good solution. So certainly feel free to reach out to us if you have specific questions, or technological concerns.
Excellent. Thank you for that, John. It looks like we do have time for just maybe a couple more here. This one's along the same lines about different locations, team members. I have a few people on my team that need dedicated boards. How might I hook those into the cloud testing while ensuring they're always available to their owners, meaning nobody else can take them?
That's a good question. We have the Virtual Lab platform provides what we call a reservation system. So every board that's been registered with Studio Virtual Lab, whether it's a simulated target or a hardware device, it has a reservation capability. That reservation can be held kind of on a manual basis, where somebody checks it out and holds on to it as long as they need it, and then they can release it when, like, if you have a board that's dedicated to you, and you know you're going to be in the office for the next 2 weeks, you can grab a reservation for that. But then if you need to go on a business trip or you have paid time off or something like that, and you want to let the rest of the team use your board while you're away, then you can release that reservation and other users will be able to access it through the virtual lab platform. That's probably the easiest way to explain it. There are slightly different, I guess, perspectives on that. The reservation itself, it can be done manually. It can be done through a schedule. So, maybe like every day, 9 to 5, you want it to be associated with you, but overnight, you want it to be available for automated tests to run. You can also, schedule it that way. There are also programmatic interfaces where a test can request a particular target right before it's going to use it, and it can release it right when it's done using it, so that you can ensure that individual tests aren't going to be stepping on each other's toes as they're executing across the various testing targets that are available at any given time.
Excellent. Thank you, John. And just one more comment, I guess, or it will be a question for you, and then we'll wrap. I'm sure some of our viewers would like to understand how Wind River can help with their specific situations. Is there a website, or what's the best way to get in touch with you?
Oh, yeah, great question. Always good to know how to reach us, right? We have our main website is available at windriver.com. That's WINDRIVER.com. And if you just go to the main page, there's a products area where you can look at all the different products we have. Obviously, there's an area specifically for Studio Developer within there. If you want an individual URL, it's just windriver.com/studio/developer. Pretty straightforward.
Excellent. Thanks, John. And just to our, sorry, go ahead. Sorry, sir, go ahead.
And there are, easy buttons if you want to talk to somebody. There, it's just one button click saying, hey, have somebody call me, and we'll reach out and talk to you, and that'll be one of our experts who can talk about everything we can do. We can discuss individual situations and really come up with a good recommendation for you.
So thank you very much to Natasha and John for an excellent Q&A. Thank you for attending today's webinar, Mastering the Art of DevOps for Embedded Systems, brought to you by Tech Online and Wind River. Thank you for your time, and we hope you have a great day.